Microphone is not on. Good afternoon, everyone. Welcome to the 2014 General Assembly of the European Geosciences Union. Thank you for joining us here in Vienna or elsewhere if you are watching us remotely. I'm Barbara Ferreira. I'm the press officer, and you can come to me or to one of my press assistants if you need anything or if you need to book a room for an interview, for example. We have organized 12 press conferences for you this week. And they include a period for questions following short presentations by the panelists. Those watching remotely can ask questions on Skype by adding EGU.media to your Skype contacts or on Twitter using the hashtag AskEGU. And there are documents related to the press conferences that are uploaded online to media.egu.eu/documents. So you can check this page throughout the week if you want press releases, presentation slides, etc. Our first press conference is on sinking coastal cities, and our speakers today are Gilles Erkens, I hope I got that right, is a researcher at the Deltars Research Institute and the University of Utrecht in the Netherlands. Pietro Tiatini is a researcher at the Department of Civil, Environmental and Architectural Engineering at the University of Padova in Italy. And Peng Liu is a researcher at the Shenzhen Key Laboratory of Spatial Information, Smart Sensing and Services at Shenzhen University, China. So I'll pass on to our speakers. Thank you.
Yeah, all right. Thanks very much. I would like to draw the attention to a problem that hasn't received too much attention, and that's that coastal cities around the world are now sinking. Next slide, please. The main points I would like to make with this presentation is that land subsidence is now outranging climate-driven sea level rise. And you can see in this figure that subsidence can be 10 times higher than sea level rise, and this is absolute sea level rise. And most of the problematic land subsidence is human-induced. So this also comes to my third point, and that the solution is in ourselves. We are the ones that can do something about this. And in contrast to sea level rise, which is a global issue, land subsidence is different for each location, so the solutions also need to be found locally. And this is also in the light of larger socio-economic developments, such as increased population in cities and urbanization, and also climate change, of course, with sea level rise, is making things worse. Next slide, please. So there are two different causes of land subsidence. You have, just to make sure that land subsidence is land level lowering, but there are two causes. So there are natural causes, which are usually geological processes, but also anthropogenic causes, and those are the human-induced ones. And to make a difference between the two is important because anthropogenic causes are usually of a much higher magnitude than the natural ones, but also the coping strategy is, of course, very different. You can do something about the anthropogenically caused land subsidence, but there is nothing we can do about the naturally caused land subsidence. The anthropogenically caused subsidence will be the main focus of this talk. And then you have resource extraction, such as oil and gas or groundwater, and drainage of soft soils, usually organic soils. And all the examples I will show today are from groundwater extraction-related subsidence. Next slide, please. These are a couple of cities around the world that have experienced land subsidence over the last decades, up to 100 years ago, and with some predictions for the future. You can see that sea level rise in the red upper line. It's much lower than the amount of land subsidence, and some cities are really on the way down, such as Bangkok, Jakarta, and Manila. And also Tokyo, of course, stands out here. But that's also the only positive point of this figure is that there is a nick point in 1975 where Tokyo did something to solve it, and I will come back to that later. Next slide, please. So in our assessment that we carried out and that resulted in a document that you can see the front page of, we asked 6 questions for each city, and cities are listed on this slide: Jakarta, Ho Chi Minh City, Dhaka, New Orleans, and Bangkok. And we asked these 6 questions: how much subsidence is there, what is causing subsidence, how much subsidence is predicted, what's the damage, what's the impact, who's responsible, and what are solutions. And it turned out that most of these cities are somewhere up on their way to solving subsidence, but are somewhere stuck at these specific questions. For instance, in New Orleans, the main question is now what is causing subsidence. In Jakarta, the question is how much subsidence is predicted, and in Tokyo, they more or less solved it. And our study got us the insights in the processes of each city, but also a research agenda for these cities, what they should do as a next step. And it gave us some information on best practices of different cities, so that, for instance, Jakarta can learn something from Tokyo. Next slide, please. The impacts of land subsidence are twofold. You have, because of general lowering of the land, you have flooding. The pictures on the left are from Jakarta. You can see the bridge, which used to be possible by boat, and now it's completely submerged. So flood duration is increasing, flood length is increasing, and flood frequency is increasing. And on the other hand, you have differential subsidence, which causes damage to structures. The pictures on the right are from New Orleans. You can see the garage driveway being not used anymore, and also the foundations of that house are clearly visible. And we also this damage to infrastructure. Next slide, please. So what can we do? I think there are two strategies we can follow, a bit analog to the climate change strategies. You have mitigation and adaptation. So mitigation is to reduce subsidence, and that can only be used for the human-induced part. It's usually technical, such as diminishing pumping or aquifer storage recovery. And then adaptation is usually for the natural subsidence and the remaining human-induced land subsidence that we cannot do anything about. And that's, we can, for instance, reintroduce sediment in deltas, but also build higher levees in deltas. And there are also non-technical measures, for instance, better spatial planning and governmental embedding to increase that. And the picture shows that groundwater levels in Tokyo have gone up because pumping stopped in the 1960s, and with a short time delay, there is land subsidence stop there. Last slide, please. My last slide is about what can the geology community provide, so us. I think we can do 3 main points. We can try to take care of better in situ measurements. We have a lot of surface measurements, but we don't know exactly what is going on in the ground. So we can have a better understanding of the causes of land subsidence. We need better subsurface models and maps. For instance, the picture on the left shows a very simple subsurface model, and the picture on the right shows for a different city, but a much more complex and also more realistic subsurface model. In this way, we can have better models and better predictions of land subsidence, so people can know what they have to deal with. And then lastly, I would say that we could advise on specific solutions, for instance, geology-based spatial planning. Which areas you can use to build new houses, which are, those areas that are not susceptible for land subsidence, and which areas are perhaps better left out for building. That's it. Thanks very much.
So good afternoon. I'm Pietro Teatini from the University of Padova, and my talk this afternoon is mainly related to one city, and the city of Venice in Italy. And the question is, which is the present subsidence of Venice, and are we able to distinguish between the natural subsidence and the subsidence due to human activities? And Venice, everybody knows, is located in the middle of its lagoon, and has experienced a lot of land subsidence and sea level rise all during the past century. And for this reason, now everybody knows that Venice is completely flooded when high tide occurs. And this in the past was due mainly also for Venice due to water pumping from the deep aquifer that are located below the city and below the lagoon. But then in the end of the 70s, more or less like in Tokyo, water pumping from the subsurface was prohibited, and so land subsidence due to water pumping stopped. But is Venice still sinking due to some human activities? And to give an answer to this question, we have, of course, we have used all the methodologies that are now available. And today there is this very powerful method that it is called SAR interferometry. So using satellite, we are able to measure with a very precision of the order of 1 millimeter the movement of urban area. And for these studies, we have used all the available satellites that provide this kind of information that covers more or less 20 years from 1992, as you can see from the map on the top left, down to more or less these years. So you can see that we are able to have an almost complete covering of measurements of all over the city. And we have tried to combine this data to see if we are able to split into the present subsidence. So we want to distinguish between the natural effect and the anthropogenic effect. To do this, what we have done, first of all, we have, let's say, interpolated the long-term subsidence provided over these 2 decades, from 1992 to 2010. And as you can see, the map is more or less green. That means that generally Venice is more or less stable if we look at a sufficiently long time period. So the natural subsidence now is very small, on the order of only 1 millimeter per year. But if we look at some specific year, for instance, in this case we have data from the year 2008, you can see that a lot of red spot come up. So there are a lot of short-term displacement that are due mainly to human activity and not to natural factor, because natural factor does not happen with such a short time interval. So we have subtract the 2 maps, and we obtain a map like this one that show where the anthropogenic affect more the movement of the city. And you can see there are red spot, that means area where the human activity are providing more subsidence than the natural, up to 4-5 millimeter per year. So there are some activity that generates in specific small area of the city much stronger subsidence than the natural one. And then we have also some other area where we have green value, so where subsidence is less than the natural value. And what are the reasons of this differential displacement and of these anthropogenic activities, or anthropogenic causes? First of all, we have to take into account that subsidence has been built up on a very heterogeneous subsoil. So we have some portion of the city that has been built on sandy soil, other part on more clay or peaty area. So this contributes significantly to this different pattern of the movement of the city. And also the city built up over the century, as this picture on the bottom shows. So there are some portion that has been built more than 1,000 years ago, that so now are more stable than the part that has been built only a few decades ago. And then there are other causes. For instance, restoration works. As you can see from this picture here, we can see that when some people want to restore their own building, they have to load with new. They have to load with new load the portion of the building or the structure, and this generate new subsidence for this group of houses or group of buildings. And this is clearly, for instance, see here in this map, and this is a photo, for instance, you can see that when they make some activity on the roof of the building, in that year, the building goes down significantly, up to more than 5 millimeter per year. A last one effect is due to the waves induced by the intensive boat and ships traffic. In fact, these continuous waves can create damages along the embankment or along the fondamenta that closes the city. And this is another factor that can induce some local problem to the stability of the building itself. Thank you. Okay.
Good afternoon, ladies and gentlemen. My talk is mainly about the subsidence mapping in Shenzhen of China. You may not have heard of Shenzhen before. It's to the north of Hong Kong. It was a small village about 30 years ago. Now, Shenzhen is the fourth largest city in China in terms of economy. It has a population of 17 million. And although the size of Shenzhen is only 1/4 of Shanghai, the economy is about similar. And so the land resource in Shenzhen is limited. The government are have reclaimed about 100 kilometers from the sea in Shenzhen. So these photos are some examples of subsidence in Shenzhen. So the upper two images show that the road is subsiding, and this image is taken at a living compound. It is said to be related with underground railway construction, and this photo shows that uneven subsidence can be a problem when you see the two buildings actually have top floors get touched with each other. They're tilting buildings. So, in order to map the subsidence in Shenzhen, we use 3 tracks of data from 2 different satellites. 2 tracks from C-band ASA and the other from L-band pulsar. One is about 5 centimeters and the other is about 24 centimeters in terms of wavelengths. And this is the mean velocity from one ASA track. We actually see some subsidence signals, the negative color in the coastal area. If you see the background, the amplitude image, you actually find that 2 area. That is the land reclamation area in Shenzhen, called the Qianhai and the Hohai. And because of a lot of construction, the surface is changing rapidly. So, and we don't expect coherent radar signals in the 2 areas. But we still find some negative signals in Shenzhen. And this is another track with some pattern here and also here. And the 2 images are C-band. So this is from L-band. We just got the L-band date. And so this is a new result. And if we look at the time series, I can show you a short video. This is from track Z5. The negative means subsiding. So we monitored the subsidence from 2007 to 2010. Okay. And this is from another scene pattern track. We also get the L-band data, but it's a bit noisy, so I will skip to the next one. When we try to plot the time series together, we found in Shenzhen the case is a bit different from the cases I have done before. The deformation isn't quite linear in Shenzhen. Actually, you find some seasonal signals. When I mean seasonal, I mean that the deformation is quite non-linear. Actually, you see consistent fluctuations periodically, and nowadays we are trying to find out the reasons for such signals. This is another point. You also see some similar trend. And so conclusion is we have found subsidence in Shenzhen, and including the land reclamation area, and we also find some seasonal deformations. Okay, that's all.
Does anyone have any questions? Christina? Could you just tell your affiliation and put the questions?
Christina Reed, I'm with ClimateWire, and questions for Dr. Liu. I was wondering, we were listening to the Venice being around 5 millimeter differences in subsidence, but in Shenzhen, what the scale of
the scale is millimeter per year. Also,
so it goes up to 30, or
I think the rate is quite seasonal. So the mean velocity actually cannot describe the deformation very well. You need to look at the time series.
So what was the maximum minimum range?
You mean the uncertainty? Okay, I will show.
In the subsidence that you saw.
Maximum rate at about I got actually, I think it's minus 5 to 5 millimeters per year.
Okay.
Okay.
Thank you. Are there any other questions?
Randy Shostak, reporter with EOS, newspaper of the American Geophysical Union. For the first speaker, I'm sorry, I forget how you pronounce your first name. But
Gilles.
Wonderful presentations, all of you. You mentioned that there hasn't been very much attention paid to this issue. I wonder if you could perhaps speculate as to why not. Perhaps all three of you could touch on that.
Yeah, so it's purely speculation, of course, but there has been much attention to sea level rise, and rightly so, because sea level rise is very important. But subsidence, it's a bit hidden, the problem, because there is no responsibility at the governmental level for subsidence, right? Often there is no institute that is responsible for subsidence, so it's not seen as a problem in the cities. And often if you have increased flooding as a result of subsidence, it is attributed to sea level rise. But it's in addition to sea level rise. Absolute sea level rise, that's the main distinction, yeah.
Yeah, I agree with him. Yeah, this is mainly the reason. So, of course, coastal cities are, let's say, are spot spread all over the world, and sea level rise is a global problem, more or less. Instead, this is occur only on some spots, and so probably, generally, it's much more feel the problem of sea level rise, but to a less face the problem of land subsidence. But of course, in this small spot, then land subsidence is much more larger than sea level rise.
Jonathan Amos, BBC. In Europe, we've lost some of our radar satellites, ERS, Envisat, but we've now got Sentinel.
Yeah.
I just wonder what difference the Sentinel Copernicus series is going to make for your work.
Yeah, we so both Earth and Envisat has been lost, and now Sentinel will come up. I think it's not already on in activity, and I think that will, of course, being newer satellite, they will provide more information, and the most advantage could be related to the revisioning time. So they will make photo of the investigated area more with a smaller frequency, and this of course allowed for more detailed measurements, more accurate measurements, and so on. But and now we are working with this satellite that are not maintenance from the European Space Agency, but local national space agency, such as TerraSAR-X, that it is from German Space Agency, and Cosmos Skymed, that are from Italian Space Agency, that are the most newest satellites that are working with this kind of sensors.
I'm Jonathan Tyrone with Bloomberg News. My question is directed, I guess, at Gilles first. You mentioned the anthropogenic causes of subsidence. How much of a new problem is this? Or is it simply that we have instruments that have far higher sensitivities than we've ever had before that allows us to measure with more granularity? And following on that, maybe one of the other two panelists or you both could answer. I mean, given that we have this extremely sensitive measurement capabilities, how are policymakers adapting the science to improve urban planning? Or how would you advise policymakers to adopt your discoveries?
So how much is new? As you can see from the figure that I showed, it was already in a couple of decades. It's ongoing subsidence, but you're right that it's because we have much better measurements now. But the second thing that's striking is that because we are now getting so low to sea level that flooding is now really increasing in Jakarta. Flooding is increasing so dramatically that they had to find out what was happening to the city. And I think specifically the 2007 flood in Jakarta was the eye-opener for many people there, that they found out that parts of North Jakarta are really, really subsiding very rapidly, up to centimeters per year. So both, I would say.
Hi, I'm Julia Rosen. I'm a freelance science writer working for EGU. You guys discussed groundwater pumping quite a bit, but I was wondering if you could talk about the role of upstream effects like dams, deforestation, land use changes that have altered the sediment budgets of these deltas.
Yeah, shall I? This was part of my PhD study, sediment budget, so I feel responsible to answer this question. So that's land subsidence is never a problem on its own, right? This is an additional aspect. So it's, of course, lack of sediment is not causing land subsidence. Land subsidence is caused by something else. But because there's a lack of sediment in deltas, there is no way to compensate for the space that has been created. And specifically, as you mentioned, dams upstream, but also anti-erosion measures that were taken, they don't help here. And I say land subsidence is never on its own because it's also related, for instance, to salinization of aquifers, because the pumping of fresh water also pumps in salt water from the sea. So it's a very complex problem, and perhaps it's also related back to your question, because it's so complex, it's also a bit hidden. It has been hidden for quite a long time, yeah.
Thank you. Are there any other questions? I think there was a question from Twitter.
Okay, I will read this question, but I'm not sure exactly what it means. It's from Arctic EU. And the question is, what can be improved in terms of partnerships for risk reduction? Are coastal cities working together? Maybe this relates to your...
Yeah, I'm not sure. I think this is something that needs to be done, working together and to learn better from each other's experience, right? I mean, the experience that we have in Venice, for instance, can be used maybe in Jakarta, or maybe in other cities which are still struggling to get the problem in their to get a grip on the problem. But there are networks now focusing on delta systems around the world. There's the Delta Alliance, and there are many more of these networks where researchers can share their experience. But this also comes back to the question, your second question that wasn't answered so far. How do policymakers get this into their hands? And that's I think that's the main problem, to get these data to policymakers and to do something with that. I mean, that's my feeling, but maybe the other two can contribute.
Yeah, because to take some mitigation strategies or something like that, of course, it has a cost, and this is at this moment is a big problem. So we can provide some information, but then let's say more or less we stop our work at this point, and then it's not too easy to see if some mitigation strategy will be implemented or not. This is the real.
Yeah, I think it's
problem.
difficult because if you see land reclamation as an effective way to solve the land resource problem, but it's a land reclamation area takes like decades, like 30 years to settle down, and I think the public can or the government can wait to build buildings on it. Sometimes it's just how you see this problem. Yeah.
Thank you. Are there any other questions from here in the room or online?
Liz Callagher from Environmental Research Web. I've got a question for Peng. What measures are Shenzhen City taking?
Pardon?
What measures is Shenzhen City taking regarding the subsidence?
What measures against subsidence the city take?
I'm not quite sure about this.
What is the city doing to mitigate the subsidence?
I think the government is doing plans to monitor subsidence using some traditional techniques like leveling, but I don't have access to this data. And for some like living compounds that is influenced by subway construction, I think both the press, the media, and the government are covering this problem. And for the land reclamation area, the two areas are still. I think the government is making some plans like 20 years or 30 years for this area. It will be like one of the economic growth point in Shenzhen for the future years. I think the government should take some measurements for the two areas.
Thank you. Are there any other questions? Julia, anything online? No? Okay. If there are no more questions, I'll thank to our speakers for really excellent presentations, and thank you all of you for coming. And the next press conference is at 3:10 on hydrological challenges facing our planet. Thank you.